Hello students, let's solve this question. 7 identical dominoes, that is blocks, are to be stacked in 3 columns. Figure gives an example. So a figure is also given to us in which there are 7 blocks. You can read, you can count, these are 7 blocks. This is 1, 2, 3, 4, 5, 6 and 7. 7 blocks. These are arranged in 3 columns A, B and C. This is an example of how to arrange these blocks. Now, in question is also given that they are pushed across a frictionless ice rink by horizontal 10 Newton force. So they are being pushed by a force of 10 Newton. Assume dominoes do not slip with respect to each other. So they are always in contact. There is no slipping between them. How many dominoes should be in each column with a minimum of 1? In A part, we need to maximize the acceleration of the dominoes. So we need to put the dominoes in such a order so that the acceleration of the dominoes could be maximum. This is the part A of the question. If you observe the diagram and it's given in the question, these are not slipping over each other. Okay, so let us assume that the mass of each dominoes is m. So the total mass of the 7 dominoes will be 7m. And if they are not slipping over each other, they can be treated as a single block. This is a single block, because there is no slipping between them. So horizontal acceleration of this block should be the force applied, which is of 10 Newton divided by mass. 7 blocks will have a total mass of 7m if one is having a mass m. So this should be the acceleration of the block. And because these are 7 masses, so mass should be 7m only in each variation of the arrangement. So acceleration is independent of the variation of arrangement. So part A, the maximum acceleration of the dominoes, this is always constant, whatever is the arrangement of the dominoes. So for the part A, arrangement could be any. So for any arrangement, acceleration will be same. Okay. Now let's proceed toward the part 2. To maximize the force on column C due to column B. Now we need to maximize the force on column C due to column B. There will be a force between B and C column. Here there will be a force between B and C column. Okay, and we need to maximize that force. To solve this, to get the maximum acceleration, maximum force on the column C, if you observe, whatever is the masses in the column C are being accelerated due to the pushing force by B. If we divide the column A and B and take them as a single block and column C as another single block, let's assume their masses are M1 and M2. This is A plus B. This is column C alone. But these three, the combined A and C and B blocks or the B columns are moving with same acceleration. And that acceleration will be provided to the block C by the force by block B or column B. So force by column B on the block on the C column FCB should be the mass of that column into acceleration. As the acceleration is constant, so for force to be maximum, mass should be maximum. For max force, this mass M2 should be max. So in order to get the maximum force between B and C column, we need to have the maximum mass of the column C, and which can be achieved by putting one block in the column A, one block in the column B, and 5 all the left out blocks in the column C. This should be the arrangement. This is the arrangement in which the force between B and C will be maximum. Okay. Now let's proceed to the next option, next question. In part C, to maximize the net force on the column B due to columns A and C. Now we need to maximize the force on the column B due to both the columns A and C. If column B and C are taken as a single block, if column A and A is left out and B and C are taken as a single block, then the force on the B and C column is accelerating them. Force due to column A on B and C, force on B column due to A, this is accelerating B and C. If the mass of B and C is, let's say, M2 and mass of A is M1, the force F should be, the force on column B due to column A should be equal to the mass M2 into acceleration. Now acceleration is constant. To get the maximum force, the mass M2 should be maximum. So to get the mass M2 should be maximum, the mass M1 will be least, because M1 plus M2 is going to be 7m. So we need to put only one block in the column A to get the maximum force on B and C. Okay, but we need to also arrange these blocks to get maximum force on column B due to C column also. By C column, the force on B should be maximum. Now, due to C, the force on B, if I put if I keep all the masses, if I take all the masses in column B to be M1 and all the masses in column C to be M2, then the force by C on B will be equal to force on B on C. Okay, and if this force was maximum, force on C due to B was maximum, then I should put maximum mass in column C. And for that I have already considered in the case 2 that all the masses which are left out by putting one block in A and B should be kept in block C, should be kept in column C. So the arrangement of this part should look like this. All the 5 blocks should be kept in the column C and one block should be kept in column A and B. So this is how the force between B and C is going to be maximum, and similarly force between A and B is going to be maximum. And this arrangement is same as the arrangement obtained in the option B. So option B and option C are having same answer, same arrangement of the blocks. Now let's proceed to the option D. To maximize the force on the column B due to column A. Now we need to maximize the force on column B due to column A. This is already calculated. If we need to maximize the force on this column B due to column A, the force between them is to be maximum. So for that, the mass of B and C combinedly should be maximum, and we can put B and C in any manner, and the mass of B and C combinedly should be 6m. So for the options D, I can arrange one block in column A and take all the 6 blocks in column B and C, and I can arrange in B and C in whatever permutation and combination possible. So this is the answer of the part D. Thank you.